Hello students, a warm welcome to all of you at AriserTalent. So, in our previous lecture, we have discussed about the corrosion and its effects and what are the necessary conditions for the corrosion to occur. And we have already dealt about the corrosion of iron, and in our today's lecture, we are going to discuss about the corrosion of aluminium, corrosion of copper and corrosion of silver. Then after this, we will talk about the another terms that is alloys and what are amalgams. So, our today's topic is corrosion, alloys and amalgam. So, today we are going to deal about corrosion, alloys and amalgams. So, about corrosion, we have discussed about in our previous class that corrosion is basically a process. It is an oxidation process in which a rusty layer is deposited on the surface of the metal due to the action of moisture, air and water. So these are the basic conditions for corrosion to occur. Now we will deal about the corrosion of aluminium, corrosion of copper and corrosion of silver. So our next topic is corrosion of aluminium. So, in case of corrosion of aluminium, what basically happens is aluminium when exposed to air, it reacts with oxygen to form an oxide layer on it, and the oxide layer, that is of Al2O3, deposited on the surface of the aluminium will make it lose to the luster and appearance of the aluminium, that it become a grayish in color. But what actually happens, this coating is so hard that it prevents the further air to enter into the oxide layer and prevent the metal from further corrosion. So in somewhat we can also say that corrosion is also a beneficial process. So actually what happens in case of aluminium, the aluminium when it is exposed to air, it form a layer around it, and this layer is basically of aluminium oxide. It form layer of aluminium oxide. This layer of aluminium oxide will make the aluminium having a dull appearance. It means its shining effect has been reduced. So what happened here? This make the dull appearance in case of this oxide layer. Now this oxide layer is so tough that the air will not going to enter in this layer and protect the metal from further corrosion. So what happened in this case? This layer is quite tough. So in this tough part, air will not be allowed to enter into the layer and further corrosion will be stopped. It will stop the further corrosion. So this scenario is all about the corrosion in case of the aluminium. It means when aluminium metal is exposed to air, a thin layer of aluminium oxide is formed. This layer is so hard and tough, it prevents the air from entering into the surface and prevent the metal from further corrosion. So I hope this topic has been clear to you. Now we are proceeding to our next topic, that what will be the effects in the case of the corrosion of copper. So our next topic is corrosion in case of copper. Now, what happens in case of the copper? Copper when exposed to air, in air there is an amount of carbon dioxide present. This copper is going to react with that carbon dioxide and forming a green colored coaty layer, that is of the CuOH whole twice CuCO3, that means it is of the copper carbonate, and it will make the appearance of the copper dull. So it will reduce the effect of the shining appearance of the copper. So what will happen in this case? Copper when it is exposed to air, when copper is exposed to air, what will happen? A green colored layer is formed. It will form a green colored layer. This green colored layer is basically of CuOH whole twice dot CuCO3, that is of copper hydroxide and copper carbonate. This layer is of CuOH whole twice CuCO3, and it will make the green colored appearance on the surface of the copper, and it will also help to react with the copper easily and making its tensile strength little bit low. So it will lead to reducing the tensile strength of the material. Now, after corrosion of aluminium and copper, we are proceeding to our next topic, that what will about the corrosion of silver. So our next topic will be corrosion of silver. This is about corrosion of aluminium we have discussed, and this is about corrosion of copper. Now, what happen in case of silver? Silver, when exposed to the air, it will not react with oxygen and other gases easily, but we know that a small amount of hydrogen sulfide gas, that is H2S, is present in the environment. This silver is going to react with H2S and forming a black colored layer, that is of the silver sulfide on its surface, and silver will lose its appearance, that it turns into the black, and we can say that silver is going to be tarnished. So what happens in case of silver? Silver, when it is exposed to air, when silver is exposed to air, it will react with H2S gas. H2S gas is basically hydrogen sulfide gas, and after reacting with it hydrogen sulfide gas, it will form a layer of silver sulfide. Layer is formed, and this layer is formed is known as Ag2S2, that is of the silver sulfide, and this layer is basically black in color, which make the silver appearance black. So this layer is basically black in color. So this is all about the corrosion in case of the silver. So we have dealt with the corrosion of iron, corrosion of aluminium, corrosion of copper, and corrosion of the silver and its basic layer that is formed in this reactions. So if you want to copy it, please copy it from here. So now we are going to proceed with our next term. After corrosion, we have a next term that are called alloys. So we are dealing with our next term, alloys. In your lower classes, you have simply heard about the term alloy. Alloy means it is basically a combination of two metals, a metal or a non-metal. So we can say that alloy is a homogeneous mixture of two metals, more than two metals, or a metal and a non-metal. We have simply heard about the term that is brass. Brass is basically a mixture of copper and zinc. So copper and zinc both are metals. So we can say that this is completely the homogeneous mixture we have. So what actually the alloys are? Here I am defining the term. Alloys are actually homogeneous mixture. This term is very important that they are the homogeneous mixture. Homo means same. It means they have the same category of the element present in them. So, alloys are actually the homogeneous mixture of more than two metals a metal and a non-metal. So, this will be the basic definition for alloy, and here we are coming to an example. We are considering the brass. Brass is actually the alloy of copper and zinc. So, we have one example here. Example is brass, and brass is actually the alloy of copper plus zinc. Here we have many more examples in the tabular form and their percentage composition, how the alloys are actually formed. Now we are considering the iron. We know iron when obtained from its ore, it is the pure form of the substance. But iron cannot be used in the pure form because when it is heated, it melted and it changes its property. It means it has been stretched and cannot be used for the further process. So what actually we have done is we are mixing some amount of carbon. It means 0.5 to 1.5% carbon is mixed with iron to make the stainless steel. And this stainless steel has a different properties apart from iron, and this is basically used as a resistant material in most of the cases. So what we are doing here is we are taking an example of iron. We know iron is actually the pure form of metal. This is pure form of metal. But this pure form of the metal cannot be used because when iron is heated or exposed to different kind of the temperature, it starts stretching its properties. So what actually happens in this case, we are mixing a small amount of carbon in case of iron, and carbon that we are adding is almost 0.5% to 1.5%. Now, when carbon is added to the iron, the basic component that is going to form is stainless steel. What we are getting? We are getting stainless steel. And this material that we are obtaining is a widely used metal we are using, that is the alloy we are using in our household utensils, and this stainless steel is completely corrosion resistant. So this product that we are getting here is completely corrosion resistant. So this is all about what actually the alloys are, the basic example of alloy and definition of alloy with regarding to iron. Now we are going to deal with next topic, that why it is necessary to make the alloys, because the metal does not have its specific characteristic to perform its function, so it is necessary to make an alloy. So what are the benefits or what are the criteria of making alloy, we are going to deal it with now. So our next topic is what are the benefits of alloys. So in dealing with benefits of the alloys, the first most important benefit is that alloys are basically chemical resistance. We have recently seen an example of iron. Iron is combined with 0.5 to 1.5% carbon to make the stainless steel. And this stainless steel is completely corrosion resistant. So the first benefit of having alloys is that these are completely chemical resistant. So first advantage is to increase chemical resistant nature. this will be the first advantage of having alloys, and its basic example here is stainless steel. Second benefit of making alloys is that it will help in lowering the melting point of a substance, melting or boiling point. So second advantage is to lower melting point, boiling point of metal. This is another second advantage we are considering about having the alloys. An example in this category is we are considering an solder. Solder is basically an alloy that contains 50% lead and 50% tin. This is used for making the electrical wires where lower melting point is required. So the basic example for this we are considering here is solder. Solder is actually an alloy, and this solder will consist of 50% tin and 50% lead. It contains 50% tin, 50% lead. This is the constituent of making alloy, that is solder, and this solder is basically used in electrical wire purposes. So where is its application? It is actually used in electrical wire purposes. So it is a second example of making alloys that it will help to lower the melting boiling point of a metal. The third advantage of having the alloys is that it will help in making the tensile strength of a substance more effective. So the third category will be to increase tensile strength. If we are considering the tensile strength of a metal, so if I am considering any metal, that is magnesium and aluminium. If I am considering magnesium and aluminium metal individually, so they have different properties and very weak tensile strength when they are alone. But when magnesium and aluminium are combined, an alloy is formed that is called magnesium, and it has basically the higher tensile strength as compared to the individual metal. So what will happen in this case? We are taken an example. We are taking an alloy that is magnesium. This magnesium is basically an alloy of magnesium and aluminium. So its constituents are magnesium and aluminium. This magnesium have a high tensile strength as compared to magnesium and aluminium. So we can say that it will have high tensile strength. So it is all about the tensile strength of a substance. Now we are going to discuss about the last benefit of making an alloy. The last benefit of making an alloy is that it will help in making the type, increasing the type of a substance and increasing the quality of a substance. So our next category will be to increase type of a metal. The basic example in this category will be the cast type metal. This cast type metal, in this metal we have increasing the casting characteristic of a substance. This type of metal contains lead, zinc and tin, and this alloy is having a very typical appearance. So it will increasing the casting of a metal. So example in this category we have is type metal. This type metal is actually an alloy of lead, tin and we have lead, tin and zinc. In this type metal, we are having a casting appearance. The casting appearance of an alloy will going to increase. So what is its benefits? Casting increases. Here are some of the benefits of making alloys in spite of being using as a metal. The basic advantages we have discussed here is to increase the chemical resistant nature of a substance, to lower melting boiling point of a substance, to increase the tensile strength, and last, to increase the casting property of a metal. So here are the some advantages of a metals in spite of being alloys. Now we are going to discuss about our next topic. After corrosion and alloys, we have our last topic, that is amalgam, and after that we are going to discuss about the type of the alloys and what are their composition of the metal and what are their uses in our day-to-day life. So before starting that, we will discuss the topic that is called amalgam. So after corrosion and alloys, we are having our last topic, that is amalgams. So what actually the amalgams are? Amalgams are the mixture of metal with mercury. So if any metal is going to combine with mercury, we can say that amalgam is formed. So what are amalgams? It is a mixture of metal and mercury. So what are the two basic components needed here? We needed metal and mercury. Now we are taking an example to understand the case of amalgam. Suppose we are combining sodium with mercury. We are combining sodium and mercury. If sodium is combined with mercury, we can say that sodium amalgam is formed. So what we are getting here? Sodium amalgam is formed. So what are actually the amalgams are used in? Amalgams have different advantages. If I am considering the sodium amalgam, it will help in decreasing the reactivity of the metal, and sometimes sodium amalgam is also used as a reducing agent. Second, in case of the cheap mirrors, silvering is done using the silver amalgam. Last is, in extraction of certain metals like gold and silver from their ores, amalgamification is used. So now we are going to deal with what are the applications of amalgam. Basic applications of amalgam are, first, it is used to make the metal less reactive, to decrease reactivity of metal. If I am considering the decrement of the reactivity of the metal, we will take the basic example, that is sodium amalgam. Sodium amalgam is used to decrease the reactivity of the sodium, and it is widely used as a reducing agent. So its example will be sodium amalgam, and this sodium amalgam is actually used as a reducing agent. So it is the first application of using the amalgams. Second application is, it is used for polishing the cheap mirrors. So its second application is to polishing cheap mirrors, or we can say that it is used for silvering the mirrors. Now its last application of the amalgams are basically in amalgamification. So third application of amalgams will be in amalgamification. In case of amalgamification, amalgams are actually used for the extraction of gold and silver from their ores. So its use will be in extraction of gold and silver from their ores. So here are the three applications of having amalgams. First one is to decrease the reactivity of the metal, second to polishing cheap mirrors, and the third application will be in the extraction of gold and silver. So this is all about corrosion, alloys and amalgams. Now we will deal with what are actually the alloys and what are their composition and what are their advantages in day-to-day life.